Hi, welcome to Chapter 3. The first topic of Chapter 3 is conditional probability. The motivation here is that the probability for getting a 1 when rolling a fair six-sided die, we know that is 1/6, and that's based on their equally likely outcomes, and there are 6 of them, so it's 1/6. However, suppose now you're given the extra information that the die roll was an odd number, so it will have to be either 1 or 3 or 5. Given this extra information, and what we say usually is conditional on this new information, the probability of getting a 1 is now 1/3 because you're choosing either 1 or 3 or 5. Formally, to define conditional probability, given two events A and B, with the condition that the probability of event B is greater than 0, then the conditional probability of event A given B has occurred is defined as this particular expression. Notice that the left-hand side is the conditional probability of A given B. On the right-hand side, on the top, we know that this is intersection of event A and B. So that means both A and B happen. In the denominator, that's just the probability of event B. And because it's in the denominator, you notice that why we need to have this requirement. So in short, the conditional probability of A given B is the ratio of the probability of A and B over the probability of B. A couple of notes here. When B is the sample space, meaning that it's the S that we used to see that contains all of the outcomes, then we know that probability of B will be the probability of the sample space, and we know that by the second axiom of probability, we know that the denominator becomes 1. So the conditional probability of A given B just becomes the probability of A. Then B is the sample space. And so mathematically from here, we're able to show that. The intuition of thinking about conditional probability is that when we have a sample space with equally likely outcomes, then the conditional probability of A given B occurs, we'll just be counting how many outcomes are there for A and B happen at the same time. And we also count how many outcomes in the sample space B, and then we take the ratio, will give us the probability of the conditional. Go back to the example earlier that when we are rolling a six-sided die, it's a fair six-sided die, and we define the event B to be 1 or 3 or 5, and then define event A to be 1. So remember, we're saying that we want to know the probability of getting a 1 if we know that we have rolled an odd number. So the probability given get 1 given that the roll is odd. By the setup of A and B here, we know that it will just be the conditional probability of A given B. By applying the formula that we covered earlier, we know that it's going to be probability of A and B over probability of B, which will be 1/6 to get A and B, because A and B, we know that will just be A itself. And then to get B, we know that it's an odd number, so we have 3 out of 6 choices. So 1/6 over 3/6 gives you 1/3, which is the conditional probability that we came up earlier through intuition as well. Now, time for you to practice. Roll 2 fair six-sided dice. Find the probability of the sum of the 2 rows of 7, given the condition that the first row is 4. Good luck.